Chapter 10.7. In the past two chapters, 10.5 and 10.6, we looked at the angles that were formed by the intersection of two secants, or a tangent and a secant, or two tangents. In this chapter, we're going to look at the lengths. If two secants or two chords intersect inside of a circle, then the products of the lengths of the chord segments are equal. In other words, in this picture, AB times BC would equal EB times BD. So for problem A, we know that CE times EA would equal DE times EB. CE has length 8, EA has length X, DE has length 12, and EB has length 9. 8x equals 108. Divide both sides by 8, and we would have that x equals 13.5. In problem B, we would do x times x plus 10 equals x plus 4 times x plus 2. Multiplying this out, we would have x squared plus 10x equals x squared plus 6x plus 8. We can subtract x squared from both sides. So we'd have 10x equals 6x plus 8. 4x equals 8, and x would equal 2. In the next problem, we can do 5 times x equals 10 times 8. So 5x would equal 80, and x would equal 16. The next problem B, we have x times x plus 20 equals x plus 8 times x plus 4. X squared plus 20x equals x squared plus 12x plus 32. Subtract x squared from both sides and continue to solve for x. We would have 8x equals 32, so x would equal 4. When two secants intersect outside of the circle or in the exterior of a circle, then we have a different theorem. In this theorem, we say that the whole length, which is here AC, times the part that's outside of the circle AB would equal the whole length AE times the portion outside, which is AD. When we're looking at solving a problem, it's best to mark your picture with the length of the whole entire segment. So the length of the segment EG would be EF plus FG, or 10 plus 24, which would give us 34. For the length EI, we would add the two segments again, EH plus HI, which would give us x plus 8. So according to the theorem, the length of the entire segment times the length of the portion outside, so EI times EH would equal the length of the entire portion, or the entire segment, times a portion that lives outside of the circle. So 34 times 10 equals x plus 8 times 8. So 340 equals 8x plus 64. Subtract 64 from both sides, we'll have 276 equals 8x. Divide both sides by 8, and we have x equals 31.5. Again, we'll figure out what the entire length of each of the sides are. So for GM, it'll be 27 plus 25, which gives us 52. The length of this side would be x plus 24. So x plus 24 times the portion that's on the outside, which is x, equals 52 times the portion that's on the outside, which is 25. So x squared plus 24x equals 1300. We have an x squared and an x, so we'll have to bring everything over to the side with the x squared. And now we'll need to factor. To do this, I need to find the factors of 1300 that would add up to be 24. And those two factors would be 50 and negative 26. So x plus 50 times x minus 26 equals 0, and you need to show all these steps. Solving x plus 50 equals 0, I would have x equals negative 50, or x minus 26 equals 0 would give us that x equals 26. I can't have a negative length, so my answer would be x equals 26. Now we're going to look at a tangent and a secant. So following the rule we had before, for this side I would do the entire length times the portion that was on the outside of the circle. For this side here, the entire length is jk, and the portion outside of the circle is also jk. So that's where we come up with this formula, jk squared equals jl times jm. The length of LJ would be x plus x plus 2, which would be 2x plus 2. Remember, you need to add these two and not multiply them to get the full length. Here we have a tangent. LM is the entire length, and LM is the portion outside of the circle. So 12 squared equals x times 2x plus 2. So 144 equals 2x squared plus 2x. So 0 equals 2x squared plus 2x minus 144. There is a GCF in each of these terms, so I'm going to divide each of the terms by 2, and I'll have 0 equals x squared plus x minus 72. So we need the factors of negative 72 that will add up to be a positive 1, or another way to look at it, the factors that are 1 apart. So 0 equals x plus 9 times x minus 8. 9 times negative 8 is negative 72. 9 plus negative 8 is 1. So here we have that x equals negative 9 or x equals 8. Can't have a negative length, so our answer would be x equals 8. For the next problem, we need to look at what the entire length is for MP. 20 plus 25 would give us a length of 45. MN is the entire length, and MN is also the portion outside of the circle. So x squared equals 45 times 20. X squared equals 900. X would equals plus or minus rad 900. Again, I know we're only looking for the positive answer, but just to keep this mathematically correct, I will continue to write plus or minus rad 900. So x equals plus or minus 30. Since it is a length, we're only going to choose the positive answer. So x equals 30. And that concludes Chapter 10.7.